Good morning, students. I am Dr.R.SUGANYA, Department of Computer Science with Cybersecurity. Today we are going to see about the sensor networks. So, a sensor or actuator network, is the same name suggests, it is a network of sensors that sense and measure their environment, or actuators that acts on their environment. The sensors are capable of communicating in a cooperative and a productive manner. So, effective and well coordinated communication and cooperation is a prominent challenge primarily because the sensors and actuators in SANETs are diverse, heterogeneous, and resource constrained. SANETs offer highly coordinated sensing and actuation capabilities. Smart homes are a type of SANET, so that displays is coordination between distributed sensors and actuators. Example, smart homes can have temperature sensors that are strategically networked with heating, ventilation, and air conditioning actuators. So, when a sensor detects a specified temperature, this can trigger an actuator to take actions and heat or cool the home as needed. The following are some advantages and disadvantages that a wireless based solution offers. Advantages: the greater deployment flexibility, especially in extreme environments or hard to reach places. Simpler scaling to a large number of nodes. Lower implementation cost, easier long term maintenance. Is effortless introduction of new sensor or actuator nodes, better equipped to handle dynamic or rapid topology changes. Disadvantages: potentially it is less secure, typically it has lower transmission speeds, it has greater level of impact influenced by environment. Wireless sensor networks. Wireless sensor networks are made up of wirelessly connected and smart objects which are sometimes referred to as nodes. The fact that there is no infrastructure to consider with WSNs, it is surely a powerful advantage for flexible deployments, but there are a variety of design constraints to consider with these wirelessly connected smart objects. So here we can see in this diagram we have moderate CPU power which is minimized energy. We have low memory which is few tens of kilobytes, embedded operating system, tiny OS. We have the lossy connection, that is low power wireless mesh predominantly, which is IEEE 802.15.4. So, and also has a narrowband media which has maximum 250 kilobits per second. And power consumption is very critical, that is energy efficiency is paramount, and battery power devices we have. The following are some of the most significant limitations of the smart objects in WSNs: limited processing power, limited memory, lossy communication, limited transmission speeds, and limited power. Smart objects with limited processing memory power and so on are often referred to as constrained nodes. So we have here the many number of nodes with average temperature, with the nodes that is having limited memory power, which is ranging from 11.7 degrees centigrade, 12.2 degrees centigrade, 12.1. Okay, so it varies with the smart objects. Wirelessly connected smart objects generally have one of the following two communication patterns. One is event driven, the other one is periodic. Transmission of sensory information is triggered only when a smart object detects a particularly event or predetermined threshold. Periodic. Transmission of sensory information occurs only at WSNs that are often an ad hoc deployments with no regard for uniform node distributions or density periodic intervals. The decision of which of these communication scheme is used depends greatly on specific applications. In some medical use cases, sensors periodically send post-operative vitals such as temperatures or blood pressure readings. Communication protocol for wireless sensor network. There are literally thousands of different types of sensors and actuators used. To further complicate these matters, WSNs are becoming increasingly heterogeneous with more sophisticated interactions. This heterogeneity is manifested in a variety of ways. WSNs are evolving from single purpose networks to more flexible multi-purpose networks. that can use specific sensor types for multiple different applications at any given time. So imagine a WSN that has multiple types of sensors, and one of these type is temperature sensor that can be flexibly used concurrently for environmental applications, weather applications, and smart farming applications. The protocols governing the communications for WSN must deal with inherent defining characteristics of WSNs and constraint devices within them. For instance, any communication protocol must be able to scale to a large number of nodes. In addition to aforementioned technical capabilities, they must also enable as needed. So here we have the keywords. Summary: wireless sensor and actuator networks are a unique computing platform that can be highly distributed and deployed in unique environments where traditional computing platforms are not typically found. So, this offers unique advantages and opportunities to interact with and influence those